In section 1.1, we will talk about finding limits graphically and be introduced to the concept of limit. This is a very important concept, so once again, please come to class prepared with as many questions as you have, and I'll do my best to answer all of them. First, let's talk about the definition of a limit. As x approaches a, the limit of f of x is L. Here's a notation for it. The limit as x approaches a value a of f of x is equal to L if all the values of f of x are close to the limit L for all the values of x that are close but not equal to a. So here's basically what that means. As x approaches a number, let's say we want to look at the number 1. As x approaches 1, what's the graph doing? Which value of y is the graph approaching? That's what we want to focus on. Now here's a theorem. It says, this is going to be an important theorem that we're going to use over and over again. As x approaches a, the limit of f of x equals to L if the limit from the left exists and the limit from the right exists, and both limits are L. Here's a notation for that. The limit as x approaches a, this little negative sign right there, which let me get to that one more time. This little negative sign right there, it means that x is going to approach a number a, but coming from the left or coming from negative infinity. And as x approaches a with a plus sign, this means that x is going to approach a from the right or from positive infinity. So negative means approach from the left, positive means approach from the right. Now this theorem says that if the limit of f of x is equal to L when x approaches a from negative infinity or from the left and from the right, then limit as x approaches a of f of x is equal to L. Then the limit exists. Let's take a look at an example. We have the limit as x approaches 1 from negative infinity, so coming from the left. Okay, so let's take a look at what's happening. So here are the values of x, and x is going to approach 1. It's going to approach this number coming from the left. So as it does that, let's look at what's happening to the graph. This is the graph right here. As x approaches 1, coming from the left. This is what the graph is behaving like. And the graph is going to approach this number, 4. Remember, by the theorem, which values of f of x are we very close to? Okay, in other words, which values of y are we getting very, very close to? So in this graph, as x approaches 1, the y values are getting very, very close to 4, coming from the left. Now let's take a look at what's happening when x approaches 1 from the right, coming this way, from positive infinity. So as x approaches 1 coming from the right, the graph is behaving this way. Okay, this is the graph. Now coming from the right, the graph is approaching this value, which is -2. So the limit of h of x as x approaches 1 from positive infinity, this is the graph coming from positive infinity, it approaches -2. Now does the limit exist as x approaches 1? Well, coming from the left, f of x approaches 4. Coming from the right, f of x approaches -2, or in this case, it's h of x. So therefore, the limit does not exist because this theorem says that as a function approaches a from the left and from the right, the limit should be the same. And it's not, therefore the limit doesn't exist. Let's take a look at another example. In this graph, we want to figure out what is the limit of f of x as x approaches 2 from the left. This negative sign, it means we are approaching 2 from the left. So coming from the left, where x is approaching 2, so we're going to approach this value 2 from the left. The graph on this side looks like this. And look at what the y values are approaching. The y values are approaching this number, which is 1. Now let's see what is happening when we approach 2 from the right. So as x approaches 2 from the right side, what does the graph look like on this side? So the graph is going to be like this. Okay, now what is this graph approaching as x comes from the right? It's approaching the same value. It's approaching 1. Okay, so therefore, by the theorem, limit of f of x as x approaches 2 from the left and from the right, it's equal to 1. Therefore, the limit is equal to 1. Now notice that we have an open circle. So even though the graph approaches 1, it doesn't actually equal to 1. Look at where the closed circle is when x equals to 2. When x equals to 2, the closed circle is there. So the actual value of the function is equal to negative 3. So f of 2 is equal to negative 3. And that's an important distinction to make, that in a limit, the values of y or f of x can approach a particular y value, but the graph may be equal to a completely different y value based on where the closed circle is. Okay, next example, let's do this one in class. So you can think about it, but we'll go over this in class. All right, this example as well, we will go over in class, but feel free to try it on your own. Okay, now we're going to talk about some graphing. This is an example of a piecewise function. A piecewise function is when the values of x are less than or equal to 2, the first function applies, and when the values of x are greater than 2, the second function applies. And we are going to learn how to graph this using a graphing utility such as Desmos, which is my personal favorite. So what I want you guys to do is I want you to pull up desmos.com. And graphing piecewise functions, takes a little bit of practice, but I'll do my best to guide you. So our function is this. It's 4 minus x squared if x is less than 2. So here's how we're going to graph this. We're going to put the function f of x equals to 4 minus x to the second power. Now here's how you put the restriction on the domain. You put a little squiggly bracket, which is right above the bracket. So you would put shift and bracket. That'll give you the squiggly bracket. And then you just simply type in what your input is. So our domain is restricted to x less than or equal to 2. Now here's how you put less than or equal to. You put the less than sign and then you press the equal sign. This gives you less than or equal to. And we're going to put 2. So what it does is it graphs a function, but only for the values of x that are 2 or less. So this is less than or equal to 2. Okay. For the square, you can use this. You can also use these inequalities for less than or equal to, less than, greater than or equal to, but I usually just put a less than and then an equal to sign, which gives me a less than or equal to. Let's graph the second part of our piecewise function. The second part, f of x is equal to 2x minus 5 if x is greater than 2. Okay, so let's put f of x equals to 2x minus 5. We want to restrict our domain, so put a space, put the squiggly bracket, x greater than 2. Okay, and then there you go. We have our graph. Now we can already tell that as x approaches 2 from the left and from the right, our limits are going to be different. So the limit is not going to exist, but let's go back to our example and finish the problem. So this is what the graph looks like that we just graphed. Now again, if you have a question on the graphing, no problem, bring it to class and I'll help you guys out. So let's take a look. As x approaches 2 from the right, okay, so x is approaching 2 coming from the right or positive infinity, the graph looks like this. It's a blue graph. So what y value is the graph approaching as x approaches 2 from the right? It's going to approach this number, which is, if you extrapolate to the y, it's equal to negative 1. Now, what happens if what is the limit of f of x as x approaches 2 from the left, coming from negative infinity? So coming from negative infinity, look at what the graph is doing. The graph goes up, and then as x approaches 2, we're coming from negative infinity, the graph is going to approach this number, which is negative 2. So from the right, the graph approaches negative 1 as x approaches 2. From the left, the graph approaches negative 2 as x approaches 2. Therefore, the limit does not exist. The limit only exists when the graph approaches the same value of y coming from the left and from the right. Okay, this next example we will do in class. So feel free to try this on your own. Feel free to graph it by yourself, get some practice in graphing, but we will go over this in class.